Hi, and welcome to this section of the Unit Conversion Tutor. And in this section, we're going to cover the topic of density, converting units associated with density. Before we do that, I need to explain to you what density really is, okay, in layman's terms, okay? Forget about math for a second. Picture a bowling ball. If I actually had one, I'd bring it in and just hold it right up here in front of you just to kind of show it off, okay? But I don't, so just picture a bowling ball right here in my hand. So you know how heavy a bowling ball is. It's pretty heavy, okay? It's about this big, okay? Now, we say that that bowling ball has certain mass, or you could say a certain weight, okay? Pretty heavy, and we say it has a certain volume. It's about this big, okay? Now, we can define the density of something. The density means exactly this. It means how heavy something is, or how much mass something has, compared to how big it is, compared to how its volume is, compared to how much volume it has, okay? It's a measure of not only how big something is, it's a measure of not only how heavy something is, but how heavy something is compared to its size. That's exactly what density means. Let me give you a further example. If you take that bowling ball, which weighs a good bit, and it's about this big, okay, and you compress it, okay, and you get it in a big crusher or something, and you squeeze that sucker down to the size of the tip of this pin, okay, this big. This is maybe an inch, half an inch on each side. But it weighs the same amount, let's say. We didn't change the weight because all we did was squish it. All the mass is still there. So it's going to weigh exactly what it did before, but now it's just smaller. We say that this new thing that we just created has more density or higher density than the big bowling ball because we've compressed its mass into a really small volume. So basically, when something is more dense than something else, it just means that it weighs more for the same volume, for the same amount of volume compared to the thing before it. Alternatively, if you compress something really small and keep its weight constant or its mass constant, you've increased its density. If you, on the other flip side, if you take something like that bowling ball, let's say we stretch it out, we make it really, really big, we make that bowling ball as big as this room, okay? But it weighs the same, let's say, because we haven't actually taken any mass away from it, we just stretched it out. Let's pretend that bowling ball was made out of Play-Doh and we could stretch it out to the size of this room. It still weighs the amount of a regular bowling ball. We can still lift this bowling ball up in our hands because we know we can lift bowling balls, right? So we can get under it, we can lift it. But now it's the size of this entire room. So now for the same mass, it actually occupies a much bigger volume. So we say it has a lower density, a very low density compared to the original bowling ball, okay? So density is a measure of how much mass something has compared to its size. So in mathematical terms, the way we write that is density is equal to the mass of something divided by its volume. The mass is, you can also think of it as the weight, okay? The weight of something divided by its volume. So how much material something has compared to how big it is. Now think about this for a second. If I have this bowling ball and it has a certain mass and I don't change the mass, if I increase this volume on the bottom and make this volume bigger and bigger and bigger, let's say the mass of this bowling ball was 5. The units don't even matter. I'm not even getting to the units left. But you know, the original bowling ball has a volume of, let's say, 10. Again, the units, I don't even care. Then you divide these two things and you would get the density. Now let's say that I make this bowling ball very small. The mass stays the same, but I make the volume very, very small. Let's say I divide by 1, because I made the volume, I've compressed this thing really, really small. You can see that in this case, I have a higher density, just like I told you to begin with, because 5 divided by 1 is 5, and this thing is just 1/2. So when I take something that has exactly the same mass and I shrink it down physically, it has a higher density. The exact opposite happens if I expand it, just like we talked about. If I have 5 kilograms or whatever, and I make it larger, maybe I make it 2,000 units big. Well, obviously this bigger number is going to make the entire density go down. Okay, I could do that division and figure it out, but the density is going to get very, very small because I'm dividing by a big number. That's probably a little bit deeper than I really need to go to cover density, but I really want you to understand what it is because we're going to do some conversions with it here, okay?